This graph is showing us two different types of antibiotics. So you see the word on the top right side, penicillin resistant and methicillin resistant. So penicillin is one type of antibiotic. It's very common, and it's the most common one prescribed especially for strep throat, and methicillin. I see on the x-axis I have years, so it goes from about 1940 to 2007. The y-axis has percentages. It says percent S. aureus resistant. So S. aureus is a type of bacteria, and so it's saying that's the percent of that type of bacteria that are either resistant to penicillin or methicillin. I then see two different types of lines. So one, the dark lines represent hospital-acquired, and the lines with the white dots or shapes represent community-acquired. Okay? So similarly here, your job is to pull out observations from this graph. Specifically this time, you need to pull out 4 detailed and relevant observations from the graph and post them below. So we want to be looking at this graph, and I'm telling you that there's at least 4 pieces of information. Let me give you an example of what's not acceptable. The x-axis shows years. Yes. Will that information help us better understand bacteria, bacteria that are resistant to antibiotics or ad use case? No. So you want to pull out 4 pieces of information that have to do with bacteria, bacteria being resistant to antibiotics, where the bacteria infections come from. Okay? So right now, this one's going to take a little bit more. So let's give about 10 minutes to work on this. Again, your job is to look at this graph, and you're going to click on the reply button, and you're going to post 4 pieces of information that you can pull from this graph. Okay? Again, if you ever have any questions about what we're doing, post it in the chat so I can help you. Otherwise, get started working on this graph now, okay? So again, right now, you should be looking at the graph and pulling out 4 pieces of information about bacteria, resistant bacteria, where they came from, and posting them in the discussion below. All right, so let's look at our post. And as we look at the post, I'm going to make some corrections just because there's a little bit of confusion about the graph, which is okay. So when I look at this graph here, what it's saying is from left to right over the course of time, it's showing the percent of that type of bacteria that are resistant to penicillin and the percent of that bacteria, so all the bacteria on the planet, that are resistant to methicillin. It then shows, okay, if that bacteria acquired its resistance and that infection that was resistant to penicillin or methicillin came from the hospital or the community. So we see here in general that antibiotic resistance for this type of bacteria started around 1940. We see that it first came from a hospital. So resistant bacteria and resistant bacteria infections started in hospitals in both cases, right? We see both the penicillin and methicillin hospital lines start first, which means that in both types of antibiotics, bacteria first became resistant to those antibiotics and people first contracted them from the hospital. All right, we see it rise over time. And then somewhere around about 1965, we start approaching close to almost 100. So what does that mean? That means around 1965, almost 100% of this S. aureus bacteria was resistant to penicillin. Okay, and specifically, these were S. aureus bacteria that were coming from hospitals. So it means if you contracted this type of bacteria from the hospital around 1965 and on, penicillin would not kill it. We see then that maybe about 10 years after the first hospital-resistant bacteria showed up, we see community acquired. So that means you could get these resistant bacteria anywhere outside of a hospital, the mall, school, stores, movie theaters, restaurants, anywhere. And they kind of increased pretty quickly. And pretty soon here, around 2007, the percentage of this bacteria that you could get from the community that could not be treated by penicillin was also around 90%, so pretty high. All right, then we see for methicillin resistant, again, we see that the first meth-resistant bacteria came from hospitals, and hospitals are where you could acquire or get them as an infection. We see it increases, and by 2007, almost 70% of this type of bacteria that came from hospitals also couldn't be treated by methicillin. So majority couldn't be treated by penicillin. They also couldn't be treated by a second antibiotic, methicillin. We see about 20 years after it first shows up in hospitals, we see it in the community, which again means you could get these bacteria as an infection anywhere outside of the hospital, and they couldn't be treated by methicillin, a second type of antibiotic. Most of them couldn't be treated by penicillin, and now almost 70% also couldn't be treated by methicillin, okay? And this was in 2007, right? So we are talking, what, about 14 years ago? All right, where do you think this would be nowadays? Do you think the numbers would be higher or lower? Do you think more of this type of bacteria today are resistant to penicillin and methicillin, or fewer are? Higher, it is. Now let me ask this question. Can we go above 100%? All right, no. And I want to clear that up because a lot of times, like advertisements, right, we'll see like 250% something something. Well, you can't have more than everything. 100% refers to all of the bacteria, and you can't have more than all of the bacteria. So this type of bacteria nowadays is 100% resistant to penicillin. To Justin's case, so Justin said maybe around 80% for methicillin. He's pretty close. It's about 90%. So, but he's very in the right direction. S. aureus bacteria, so we're saying about 85 to 90% of them nowadays are resistant to methicillin. So it means the two most common antibiotics used, penicillin and methicillin, cannot kill this type of bacteria, okay? And again, it also originated from hospitals, which confirms what we saw in that CDC poster, right? And so maybe that gets us starting to think about, a lot of us asked, right, well, was the hospital not clean? How could there be bacteria on the ECMO tubes? Why would they put that in her? So we want to start thinking about what this might mean. All right, so now we have 3.11 public transportation abstract. Now I'm going to start by saying this reading is going to be a little bit more difficult. I am going to read it out loud, but it'll be your job initially to interpret most of it. So it says here, a third question we asked after watching the video was, where are the bacteria? Do some places have more bacteria than others? And that gets to what we did for our Do Now today. This scientific article describes research that was conducted on exactly this topic. So that's what they did. They swabbed and took samples from all different types of surfaces and areas to figure out which type of surfaces and areas would have more bacteria. So I'm going to read this aloud to help us out. And your job, similar to the other ones, is to post a response about which type of environments or surfaces have more bacteria and which areas have less, based off what they tell us in this article, okay? Again, just like any discussion, you're going to click the reply button and post it. So again, you're trying to pay attention for which areas or surfaces have more bacteria and which areas and surfaces have less bacteria. All right, so it says, our goal was to determine the diversity and abundance of Staphylococcus bacteria on different components of a public transportation system in a mid-sized US city, Portland, Oregon, and to examine the level of drug resistance in these bacteria. What is a public transportation system?
Like trains and buses?
Yeah, trains, buses, that you might take to and from work every day. Okay, so that's kind of the area they were testing. We're going to skip the method area and we're going to move on here to the results. So it says, we found a range of pathogenic Staphylococcus species. What does pathogenic mean? Like a pathogen. If you hear that word, what does that make you think of? Pathogenic. Staphylococcus is the type of bacteria, but it's saying they're pathogenic. If I tell you that COVID is pathogenic, what does that make you think about Staphylococcus being pathogenic? Okay, so again, if I tell you that COVID is pathogenic, Ebola is pathogenic, what do you think they mean when they say they found a range of pathogenic species?
It came from like an animal.
Okay. So my question is, does COVID always come from a non-human animal? Is that how everyone gets COVID? What does pathogenic mean? You are sitting on a computer with internet. What does pathogenic mean? Good, Bryce. It causes disease. So they're saying they found a range of Staphylococcus bacteria that were not good bacteria. They're not the kind that help us and keep us healthy. They're the kind that make us sick, okay? So the mean bacterial colony counts were 97.1 on bus and train floors. So mean refers to average, right? So the average bacterial colony counts were 97 bacterial colonies on bus and train floors, 80 bacterial colonies in cloth seats, 9.5 bacterial colonies on handrails, 8.6 bacterial colonies on seats and armrests at the bus stops, 3.8 bacterial colonies on the underside of seats, 2.2 bacterial colonies on windows, and 1.8 bacterial colonies on vinyl seats. Okay, and then they also show that in the graph here. So your job right now, okay, in the discussion is to post the types of areas or surfaces that have higher amounts of bacteria and the types of areas of surfaces that have less bacteria. Okay, so right now, post this in the discussion, the types of areas that they found that have more bacteria and the types of areas they found that have less bacteria. All right, so let's do that. I'll give you about 5 minutes to complete that comfortably. You are to just answer that question completely. So what are the surfaces that have lots of bacteria and what are the surfaces that have fewer bacteria? All right, so let's go over this and then you guys can get started working on your homework assignment for today. So we see that floors and cloth seats have the highest amount of bacteria. I don't think the floor part surprised anyone, right? Because we walk all over it, people's shoes are dirty, people drop stuff on the floor, so I don't think that really surprised anyone. Cloth seats though, and specifically cloth seats, they said had 80 bacterial colonies, but vinyl seats only had 1 to 2 colonies. What type of material is vinyl? What type of material is vinyl? Good, Lanya. It's like a plastic, right? So when you either have cushiony seats with the plastic covering, or like on most transportation, right? The seats are like your chairs at school. They are hard plastic, right? Why do you think there would be less bacteria on the plastic seats than the cloth seats? Why do you think there would be less bacteria on a plastic seat than a cloth seat? All right, Pierre, one, it's easier to clean, right? I mean, I can take any cleaning spray I want to these chairs at school and wipe them down. I'm not taking Clorox, bleach, and Windex to the cushions in the couch in my house or in a movie theater and wiping them down. Okay, one, they're easier to clean. Let's think about too what cloth is. Cloth is what? Hundreds of thousands to millions of perfect, Lanya, perfect. Actually, in the right direction, yes. Plastic, she said, is less porous. So what is cloth? Very porous, right? Cloth absorbs odors. If we spill stuff on our couch, it absorbs it. Why? Because it's just hundreds of thousands to millions of these strings woven together to make cloth. Well, when I have something woven like this, what do I have? I have all these holes or pores where stuff can get trapped in. I have all these grooves and textures that things can stick to. And so any surface that has more grooves and texture is naturally going to hold more gunk. It could be dirt, dust, or bacteria, because it's more difficult to clean, like Pierre said, but it also has more holes and openings, like Lanya said. Anything that's a solid surface is going to have less bacteria because there's not as much for them to get stuck into and kind of start living in. It's easy to clean these surfaces, so we don't see it as often. Okay. So again, we want to keep thinking about this because in our next class, we're going to start brainstorming where you guys want me to swab for bacteria. And we have to think about why those areas would be good areas. Okay. So your homework assignment here is the short reading on MRSA. So we know that Addie had MRSA, right? When she went to the second hospital, she developed boils all over her body. They swabbed and tested the boils and they found that she had MRSA bacteria. So your job is to read this. You can see it's not very long, okay? There's a lot of blank pages, that's my fault. But it's a little over 2 pages, but look at also all the white space, okay? So it's not too bad. Your job then is to read this article and identify 4 big ideas or 4 important pieces of information from the reading, okay? Now, a big idea doesn't mean like some overly detailed factoid or piece of information. So, like, approximately 5% of patients in the US hospitals carry MRSA. That's not a big idea. That's a very small, specific piece of information or fact from the reading. A big idea would mean if I didn't read the article, but I read your big ideas, I should have a good summary of everything talked about in the reading, okay? So you can think of it like a summary as well. So your homework, this is due tomorrow night, but some of you might be able to finish it pretty quickly today, is to read this article on MRSA, and then you are to reply down here. So you just click on the reply button with your summary of the article or your 4 big ideas from the article, okay? Now to remind us of what the schedule is and remind myself, we get out of here at 9:45 and your next class, 5th hour, starts at 9:50, okay? So again, this is your homework assignment. It is due tomorrow night. If you finish it today, even better. Does anyone have any questions about this assignment or what you're supposed to do? Okay, then you guys can get started working on this. If you would prefer to leave to work on it, I am fine with that as well.